conventions discussion. Because whenever one object is completing one revolution, it is completing 360 degrees journey. In 360 journey, to understand how it is moving and what are the positions, we can divide as many as possible classifications. Just we are going to take two mutually intersecting axes, that is nothing but x dash, this is the one axis, and y dash, two axes, mutually perpendicular axis dividing one circle. Then we can find that four quadrants, four parts we can see. This is the first quadrant. We can see this as a first quadrant. Next, second one. Next, third quadrant. And next, fourth quadrant. So we know that four are dividing into equal parts. That's why each can cover 90 degrees. 90 degrees. This first one is 90. Mean from where it is 0 to 90. Means from x-axis, positive x-axis, if it starts in anti-clockwise direction. Suppose I want to measure that in anti-clockwise direction, this way, anti-clockwise direction. I can take that from 0 to 90. 0 to 90. If that is the 0 to 90 case, I can take that as what? First quadrant. Next, after that, where it starts, you can say that this is the first quadrant. This is the first quadrant. From x to y. X to y. So what is the angle? From 0 it has started, and with 90 it is going to end. So in between this, whatever the angle is there, that we are going to say, or in whichever portion it is stopped, we can say that it is in the first quadrant. Next, the second one, we can say from 90 to 90 degrees to 90 degrees. This is the second quadrant. From 90 to this, another 90. In between that, if you want to take, or if you want to understand that from the very beginning, the angle is going to be how much? Angle is going to be from 0 to 180. 0 to 180. Or otherwise, second quadrant, just it is there after 90 and 180. Between these two limits only it is. Next, another 9. Another 9. This is another 90. In between 180 plus 90, 270. Another 90. 270 plus 90 means 360. In case of these four quadrants, we understood just to understand the motion of any object or something, whatever rotating, that classification, that journey is going to be in four ways. Four ways. First quadrant, second quadrant, like this. Okay. So, and there, what axes are representing, if those are in basic coordinate system, how we can represent and how that is different here, we can understand. The first thing is, whenever it is completing its 360 degrees, its angles, if something tan theta or whatever, 6 ratios, standard ratios, whatever you have taken, that ratios, if you measure in first quadrant, if you measure it in first quadrant, that is all positive values can be. That's why we have one formula here, just a logic to remember, all silver tea cups, all silver tea cups. What it means, in the first quadrant, for whatever ratio you measure the values, what are those? It is a sine theta, cos theta, tan theta. And for them, whatever the reciprocals are there, for sine theta, cosecant theta, for cos theta, it is secant theta, and tan theta, cot theta. These are reciprocals to one another. This set is reciprocal to the following. Whatever these 6 values are there, all can be positive values in case of angle. If theta is in between 0 and 90, 0 and 90, 0 and 90. So these values are going to be all positive values, all positive for all these. In case of first quadrant, that's why we are saying all. Next, in case of second quadrants, we know that it is indicated with the silver. Silver. Silver means whatever S with S starts, that is S means sine. Sine theta and its reciprocal. And its reciprocal. What is its reciprocal? Cosecant theta. You can observe here. Its reciprocal is cosecant theta. These two can be positive. These two can be positive. A remaining will be negative. Remaining will be negative. Comes to the third quadrant. What is the angle here? This is in between 90 and 180. In between 90 and 180. Then let's come to the third quadrant. In case of this is the first quadrant, next the second is finished. Next we come to the third quadrant. In case of third quadrant, what is there? T. T is there. T means tan theta. We are going to write it tan theta. What is its reciprocal? It is a cot theta. That tan theta and cot theta values are going to be positive in the third quadrant. In the third quadrant. What about remaining? Remaining ratios of trigonometry can have negative values. Remaining are going to be having negative values. That we have to remember. Next, in fourth quadrant, the angle we can remember in between, just it is a 180 to 270. Means it is greater than or equals, or that conditions also there. In detail, we will talk about. Just we are talking about 1990, like that's all. Okay. And next, exactly why I'm saying this here, 180 is a common. Then we may get a doubt where it is. Is it surely belongs to second quadrant or third quadrant? That we will talk later. Next, we go for fourth one. It is a C cups, all silver tea cups, or all initial letters are going to be said. C is going to start with cos theta. Of course, why not cosecant theta? Means that's already covered related to sine theta. That's why we are going to talk about cos theta, and its reciprocal is secant theta. Its reciprocal is secant theta. These two are going to have the positive values if the values are lying, or values 270 to 360. These values are there. Those are going to have the positive values. Remaining ratios, whatever are there, sine or tan, like that, whatever remaining are there, in the fourth quadrant, if you take the values, those are going to give us what? Negative values. That's why we are discussing this. It's a very important to understand why and what value is going to be for various angles whenever it is covering one complete rotation. Right. In detail, we will talk about in the next video, and what are the limits, why we say the values are going to be in between these two, and what I said here also, 270 and 180, that limits also we will discuss in the next video. Right.